And this is described in the Griffin book on water economics. If we have a linear demand curve, what's elasticity? We know elasticity is something that's based on the slope and the ratio of price to quantity. So elasticity by definition is change in quantity with respect to price times price over quantity. And the derivative here is just a slope. So it becomes B here. And I need to know the current price and the current consumption. If I know the current price and the current consumption, I am done. Okay? I can find what B is and what A are. So that's one way to get a function. But there is another one that's even simpler. If you assume it's constant elasticity or log-log form, which means quantity is a function of price, but it's in a log-log form like a Copda glass, then the elasticity obviously is E, the exponent here. So basically, if I know the elasticity, if I know the price, if I know the quantity, I can know K. There is only one number to calculate. And once I know K, I have the demand curve. So this is point expansion, and it's very effective if you have no better ways to estimate demand. So is an example there. So what we are doing is starting at a point where we have knowledge of elasticity. It doesn't matter how you get that. And then you know what people are buying at a particular price, because that's easy to find for a city. So I can find that. Then if I assume it's linear, then I can work out what the demand curve is. And if I assume it's constant elasticity, then I can find what that is. So around that point, my assumption about the form might not mean much, but if I go further away from the point, then they tell different stories. If I am choosing between the two, then I might have to use my judgment about which one is likely to be more believable to choose between the two. So this is kind of stuff you do if you have no other option, and it's very effective. You can build proper models for demand. But if you are studying the demand for water, this is more interesting for us. Previous was more about econometrics. What are the issues you need to worry about or to be careful about? Well, the price data that you see, what is it? Is it average or marginal price? So when people are reacting to the price, normally you would think to the marginal price, but do they know what the marginal price is? So do I know when I go home today, do I know what extra cost I would incur if I use more water on the lawn? Or do I just know on average what water is costing me? In most cases, people don't know the marginal price. And when you get the data you get are not reflecting the marginal price, they are the average price. That's one problem. How many people know what the price of water is? Even people who pay water bills, most do not know what the price. They don't pay attention. Why is that? Water is a small component in their budget. It's lower than electricity. The other thing is the way the utilities provide information is also not ideal, because it's lagged. By the time I get my bill, I cannot remember how much water I used. It was a long time ago, 2 months. And it used to be even longer sometimes. Like I think 2 months is more recent, isn't it? It used to be 6 months. Yeah. So there is no correlation between behavior and pricing. It's just two different things. That's one. But you have to also remember the data, the actual use is affected by a lot of things that might not be in your sample, or in your information, which is like temperature, rainfall, and so on. And of course, we already know that what form you use could mean different things, and those are things that you need to be careful about. There have been a lot of empirical studies on water. Actually, I have invited one of our PhD students to come and talk to you because he is doing a meta-analysis of elastic estimates, actual studies. So he will come and we'll find out more than what I have here. But estimates vary a lot. In the Griffin book, for example, you can read, but on average they tend to be low. Residential water demand is inelastic, and that's what you would expect. Does that mean we should be discouraged from using price to manage water scarcity? Is that what it means? So you want to convince somebody, a politician or a government, to take pricing more seriously and they come and say, well, it's very low, this isn't the way to go, we'll just have other ways of doing it instead of pushing the price so high that we annoy a lot of people to gain very little in terms of reductions in demand. How would you argue? Well, there are a few things to think about. One thing to remember is elasticity values change over time. So a lot of the evidence is from the past, and if water prices are going up, maybe it's not a good reflection of what's happening currently. So if you go back in time, you need to remember when prices go up, people are likely to be more sensitive to prices. So the elasticities might not stay the same. They might go up. That's one thing. Another thing to remember is long-run elasticities are higher than short-run ones. So what does that mean? In the long run, you have more options to manage things. And it's the same with water. In the long run, you are going to plan. I am going to plan my artificial lawn, okay, over the next 2 years if I have to. But in general, you are going to get more efficient washers and whatever you could do. So it's good to remember that what you observe isn't given. It could change. But the other thing is non-residential urban water demand is more elastic than household demand. Is there anything else we need to know? Even with household demand, the demand for indoor use is not the same as the outdoor use. The outdoor use has to be more elastic because it's more discretionary. So you would expect people to react more in terms of their outdoor use.